Now, I would like to call upon Mr. Jayanth Mondi for the next presentation. Thank you.
Good morning, everyone, or I should say good afternoon. I'm Jayanth Mondi, data science advisor from Global Operations, based out of the Bangalore Technology Center here from ExxonMobil. And I'm backfilling for Michelle Tugels, who is the strategy and innovation manager in the process operations space. And the topic that I would be discussing on is the enterprise AI value capture at scale, and the key enabler being an open digital ecosystem of plug and play. So this is a slide which covers a lot of the message in total. Yep. Uh, we are kind of looking at evolving technology space. Yes. The key context that we understand from the industry is on the work. Firstly, the workflows, demographics. There are two elements to it. One is the change that's happening in the generation, and second is the wide variety of employees that we work with at site, the engineers at the technology centers, and also the third party vendor solutions who we actively work with. Second is the excellence at global scale. We are trying to push the bar. We've seen great progress in this space, where earlier it used to be difficult to operate or kind of consider a trip or handle a situation of a equipment trip. Now we've gone past way beyond that, and that's kind of pushing us even more for higher expectations. AI, I think we've all known, but the key consequence of AI that we see is the innovation, the speed of innovation cycle that is being accelerated multifold, and that is key where it's testing or challenging our current traditional iterative methods that we have. So that is the key consequence that we need to be mindful of, and the growing considerations about the resiliency and the security aspects of the solutions that are being developed in this space. What we believe the future state of the operations or the solutions would look like is threefold. One is the visual way of working, where a lot of the systems could be interactive and made available for as a single pane of glass, and you could potentially come up with insights from that environment itself. So the illustration there, we see you have a rendering of equipment, and we are able to kind of collate different types of data and identify potential issues with the scenario over there of the reality of the equipment there. The second is the conversational way of working. Again, we've know how ChatGPT has evolved. So using the proprietary data and overlaying your the capabilities of the Gen AI and the LLMs would be key in enabling some of those elements. And then moving forward would be a guided way of working where it's beyond just the generic usage, but as a step towards that autonomous systems, where you could potentially have systems being fed with enough knowledge so that they could operate and guide us in a way that a lot of our experts have been doing. And it also ties back, a lot of these ties back to that industrial context on the changing workforce and the security and the governance that we need to make sure. And for this to happen, what we believe is the open and interoperable ecosystem would be the only way that could essentially manage the scale at which we are operating things. So you need to develop the tools, you have to deploy them and sustain them at scale. So a single a vendor or a single ecosystem would not fit. So you would need to have a ecosystem where you have different modular elements which can interact with one another, and that would be the only way that we can scale at pace and sustain it at pace. So this is an example of a heat exchanger, just to kind of highlight the complexity of the operations and the scale that we are looking at, and what are the current challenges associated with that. So as you see, you have multiple different user personas that we engage for a simple heat exchanger, and we have nearly thousands of heat exchangers at our sites. So the you have process engineers, equipment engineers, your operators at sites, your maintenance technicians, and your economists. Each of them perceive the heat exchanger in a different fashion, and that is one of the challenge that we see. And the way the chart on the bottom is more on the typical processes and systems that are associated with oil and gas facility, on how the end-to-end workflow would look like, and heat exchanger would be represented in some fashion and at each of the levels. But the key thing there is they are very different in the way they are looking at heat exchanger itself. So for production planning, you might just have a simple number, but for advanced process control, you would have a high fidelity model that looks at the system in detail. So those are some of the concerns that we see that are existing in the current state, where your equipment is defined in your multiple systems. The data is captured in the models, but it has its own boundaries, where one system does not necessarily talk with another. And the analytics that we would want to do would essentially combine a lot of these different types of data. That is again a challenge that we are seeing, the data availability and the quality of the data, and the high diversity of user persona. So this is again going back to the point that I was making on the workforce as well, the changing times and also the different user personas that we have interacting with that looks at the data in a different way. For somebody from maintenance technician, the inventory accuracy might be a completely different number compared to somebody from economist who's looking at supply demand dynamics and their version of what inventory mean. Lack of integration drives cost and complexity. Protecting IP, again, the point that I was making earlier on the security and the reliability of the systems. That's another key thing that is still existing. And many use cases are not justified and not ready probably for the Gen AI use cases yet from a data perspective. So these are the existing situations that we are working with. What AI brings is, yes, it gives us a way where you can scale, but it still does not solve a lot of these problems. In fact, it amplifies the gaps more, and that brings to the need to have more uh, guidelines on the data itself to start with. So that is one of the key message that I want to give as part of this example on how AI is, what AI could bring to the table. So how do we look at this scenario? So I'm taking an example of a medical analogy here, where you have different types of data. So if you have to kind of come with a analogy in the medical industry, you have anatomy, which essentially says what are the different components, where the physical location of them exists. The physiology is what's happening on how the different components are interacting with one another. And the third is intervention, where with this understanding of the anatomy and physiology, you could potentially recommend or mitigate some of the issues that you often see. So similar way for the process industry or the oil and gas specifically, we have the anatomy. Sorry. So for the anatomy piece, what we see is in ExxonMobil we have something called as the digital reality ecosystem, which captures a lot of that realistic understanding of the different entities. The process space is something that we are trying to evolve a bit more. So that's the physiology space that we want to kind of involve more. And then you would lean more into the intervention space. So from the data sets point of view, as I mentioned, these are the different components of data that we see are important as part of the open digital ecosystem. And with earlier works that we've done and with collaboration with the ARC community, the asset structure space has progressed a lot and matured a lot in a good way, where the digital reality ecosystem that I mentioned, that is a good case that we were able to identify. So tying back to that earlier example, a lot of the P&ID and the document information are being captured and made available in an interactive way. And there is obviously scope more to improve on. But all these other elements are also key things that we need to make sure that we improve on as a community. So this is how we look at solutioning for a particular systems. So you could often you have single platform solutions, multi-platform, or custom-made solutions. Each of them have their own pros and cons associated to cost, innovation, and complexity to the user. But the key message here that I would want to look at is the software would change with time, or the AI would change with time. So to drive your short-term value, yes, you could invest you need to invest in the software or the AI, but a long-term investment should, or you'll be benefiting on a longer term if you invest more in your data, especially in your data content and the quality and the semantics. And I think earlier talk also we've looked at the similar theme where the data is required, or a good quality data is needed for good insights. So as I mentioned, we have wide range of data, type of data from engineering, real time to generative AI space as well. But we also have a technical debt where a lot of these data are siloed, or it's complex and it's also or it would be expensive to kind of bring it onto a common platform. So that's the technical debt that we are currently in. And the aspiration here is to kind of move towards a more open space. So that's the pitch for the open digital ecosystem, where different entities can work in together. And one of the new technologies that we've already looked at or is around the knowledge graphs, which can interact or kind of stitch the different types of data together. So we're kind of looking at some of those elements, or expecting collaborations potentially from the market and the community in that space as well. So what do we do with that, the open digital ecosystem? We would want to kind of prioritize our use cases for value generation. Here I've mentioned about the asset lifecycle and the operation phase, but those are predominantly high IP risk use cases. But what we feel is HasOp could be one of a good use case which could be automated or augmented with AI, because it's an industry standard process, and the benefit is real. There is efficiency and effectiveness play as well, where it takes a lot of time for the HasOp to be created, and again there are challenges on the quality as well. So how can we leverage AI in that space? And from a IP perspective, because these are SHE critical elements or asset classes, we have a lesser IP restriction, so we are more open for collaboration in that space of HasOp. And it would be a foundational enabler for the higher IP cases, as mentioned above, where based on the learnings from this, we could potentially have other use cases being driven in parallel. So the call to action here for the community is to engage us or engage with us in this AI augmented HAZOP as a test case, uh, as a key enabler, and we are kind of looking at some of these potentially starting off soon. So Michel Tugels, who's our strategy and innovation manager, so he's kind of driving a lot of these initiative on AI augmented HAZOP. So to conclude, yeah, combining the engineering discipline, so the third party or the engineering rigorous models combined with AI, yes, that would enable us scale and fleet level monitoring and capabilities. But at the same time, we would need to be open so that we have a way in which we can scale and maintain it and sustain it at scale. And finally, on the AI augmented HAZOP as a call for action for the community. Yep, that's mostly what I had. Yep. Thank you.